Hello guys, welcome back to Maison African Motives, still on mathematics N4, that is working on the derivatives, differential calculus. We are going to be focusing on the first principles. Actually, this was the first part that we were supposed to talk about, but I decided to work on the general rule before the first principle so that at least we understand what is actually happening. And if we are to apply this, we know exactly what are we going to obtain in order for us to differentiate such typical questions. So we're going to focus. There's so many questions that we have got in this class. So before we talk about the first principles, the question that we have here, let us just have a basic understanding of what we exactly are we referring to. If we are given, let's say, given f of x, let's say we have got our f of x or y, which is equal to f of x like this. Remember, I was saying the derivative of y with respect to x can be also be given as the first derivative with respect to x. All right, so this is the same thing. So we are simply saying for a given y or given f of x, its first derivative with respect to x can be taken from the first principles, which states that the derivative of y with respect to x is equal to the limit as h is approaching to 0 in this case. So we're going to have inside f of x plus h minus f of x, which is our original function. That is the one that you're given there, everything over h. So this is the formula that you're going to apply or use. So how to use this formula or how to apply this formula, this is what you're going to explain in this platform. Also, you must know how to expand brackets, such as of this format. Remember, a plus b to the exponent of 2 is equal to a squared plus 2ab plus b squared. This is like an identity that you need to understand. So that if you are given x plus h, when it is given as x plus h squared like this, you know that where there is a is just x. So this is going to be x squared plus 2ab, which is 2xh. So you're going to have 2xh plus b squared, which is h squared. So by just knowing these expansion of brackets, it helps us also to shorten our working and also to understand your binomial expansion. That part of binomial expansion, I think we talked about it on a separate video. So make sure that you watch it if you don't understand, so that you will be together with us in this platform. All right, like I said, we've got questions that you're going to consider. April 2021, question number 3, differentiate from first principles if given y is equal to 5x to the exponent of 5 minus 2x, and that is 5 marks for that. All right, so this is the question that you're given. I'm gonna have it written again. So we are given that y is equal to 5x to the exponent of 5 minus 2x, and we are supposed to apply or to use the first principles, 5 marks for that. All right, so this is what is going to happen, guys. Remember, I said y representing f of x is or can be written in this case as f of x is equal to the function, this part that has got x, which is 5x to the exponent of 5 minus 2x. All right, so this is our f of x. But if we are to consider, we saw that on our formula, the one that we wrote before, we said the derivative of y with respect to x can be given as the limit of h approaching to 0. Then we have got f of x plus h minus f of x, everything over h. This is what we saw from our formula in this case. So if we are to use this concept, or if we are to apply this concept, we can see that there is a need for us to have f of x plus h. Already f of x is there, but we do not have this f of x plus h. So where are we going to obtain it? It simply means from our f of x, we are going to substitute back. All right, so let us just do this calculation aside. Let us just put this way so that we can calculate our f of x plus h. So it simply means in place of x, you substitute x plus h. So meaning to say, we are going to have our f of x plus h in this case as in place of x. So we're going to have 5 into x plus h to the exponent of 5 minus, in place of x, we substitute x plus h. So this is going to be minus 2 into x plus h, like this. So what we need is to expand this. This is our f of x plus h. Let us try to expand. Then we bring this back to our formula. To the exponent of 5. This is something else. Meaning to say, here we are supposed to apply our binomial expansion. Remember, from our binomial expansion, I explained this before, so I'm not going to go back to explain that. I'm just going to explain direct on the question. So this part, it simply means 5 is being raised. 5 is going to expand the whole bracket that we are going to obtain later on. So this 5 does not affect us for now. So we're going to have 5 into whatever that we are going to have after expanding this from our binomial expansion, whereby I was saying the first term x is raised to the exponent that you're given, which is 5. So that's x to the exponent of 5 plus this h was supposed to be at 0. So h to the exponent of 0, guys, remember I said this one is h to the, which is 1. So there's no need for us to write this. So it's just a 1. We move on. 5 decreases. This 5 is decreasing, but you do it like as a derivative. Remember, I was saying you do it as a derivative. You multiply here, you subtract 1. So that is the concept that you're going to do. So you're going to multiply by 5. So it's 5 times 1, which is 5. So this is going to be 5x to the exponent. We subtract 1. So this is now at 4. While it h is increasing, it was at 0 here. So now it's at 1 over 1 factorial, of which 1 factorial, guys, this is just 1. All right, we do the same thing. We drop the exponent for 4 times 5, 4 and 5, which is 20. X to the exponent, we subtract 1, which is 3. And this h is increasing. So it's h to the exponent of 3 in this case. Sorry, it was 1. So it's now to the exponent of 2. Everything over 2 factorial. So we are going to expand this up to the last term of 5. But I want you to take note of something. If you consider first principles, if you check properly your calculations, there is an h which is in the denominator here. If you check here, there is h in the denominator, this one. This h is going to cancel with the h that you're going to factor out from the two factors that you're going to obtain from the two terms that you subtract here. You're going to obtain an expression that is in terms of h. So you were supposed to divide by this h so that you get rid of this h. So if you understand this, or if you keep this in mind, it is going to tell us that these h's that we are going to have after these ones, h to the exponent of 3 to the exponent of 4, because the last term was supposed to be to the exponent of 5 in terms of h. They are all not even necessary, because the moment we cancel, because remember we are going to factor out h. So if we factor out h, just imagine from h to the exponent of 3, you factor out h, you are going to remain with h to the exponent of 2. Meaning to say, there is nothing that we are going to, we are not getting anything, because that h is being, or it is going to be represented with a 0 here. We are told that h is going to approximate to 0. So knowing that these h's that we are going to have later on, they are useless in our expression or in our simplification. Therefore, there is no need for us to have more of this expansion up to the end. No, just 3 terms or even 4 terms, they are fine. Just if you can expand up to 2 terms, it's fine. So even up to 3 terms, I mean, so here we can just write plus and so on and so on. Even just 4 terms, they are even fine. So this is what you're going to have from our binomial expansion. So like I said, you can even do as much, expand as much as you can. All right. After that, the binomial expansion, there is a -2, which is multiplying x. So it's -2 times x, which is going to give us -2x, -2 times h, which is going to give us -2h. All right. So what you're going to do, like I said, the 5 outside the bracket is waiting for us to simplify first. Whatever that you're going to have in this case, it is going to be affected with this part of 5. So here we are going to have x to the exponent of 5. The first part is not going to change. You divide 5, divide by 1 factorial. This is going to remain as 5. So it's 5x to the exponent of 4h. plus 20 divided by 2 factorial. This is going to give us 10. So that's 10x to the exponent of 3h squared plus and so on and so on and so on. So these ones, they are not even necessary. So we are going to just leave it like that, close the bracket at this term because we know there are terms that are there that are not necessary, all right? Then we've got minus 2x minus 2h. All right, expand this part 5 times the first, this is same as 1, so it's 5 times 1, which is 5x to the exponent of 5, 5 and 5, which is going to give us 25x to the exponent of 4, h, that is h in this case, so we've got h here, plus 5 times this 10, which is going to be 50, so we've got 50, x to the exponent of 3, this is to the exponent of 4. Why am I writing my 4 like h? This is 4 here, guys. All right. So that is a 4 there. And this is h squared. All right. Remember, we said there are so many digits that we are going to have plus and so on and so on and so on. Then we are going to have minus 2x minus 2h. All right. So this is from our f of x plus h. Whatever that we obtained from our f of x plus h, it is going to be taken back. So I want you to take this as it is, this part here as it is. This is our f of x plus h as it is, this part. We are going to substitute this back into the formula that we are given before. So I want us to get back to our formula. So like I said, take note of this part as it is. We are going back now to our formula here. Remember, our formula is saying for us to determine the derivative of y with respect to x, we are supposed to have f of x plus h. So here we are going to say the derivative of y with respect to x is equal to the limit as h is approaching to 0 of f of x plus h, or f of x plus h. Remember that value that I gave you is 5x to the exponent of 5 plus 25x to the exponent of 4h plus 50 x to the exponent of 3 h squared. Then we've got, that was 3 terms. Then we've got minus 2x minus 2h. So we're going to have minus 2x like this, minus 2x minus 2h. And we are going to subtract f of x. Take note, this is our f of x here. Please be careful on this part. This is our f of x here. This part is representing our f of x. So meaning to say the minus is going to affect every term. So it's minus times 5x to the exponent of 5, which is minus 5x to the exponent of 5. Then it's minus times this minus 2. So it is going to be a plus 2x in this case. So this is what you're going to have at the end, and everything here is over h. So everything is being affected by h. Now, we cannot substitute the limits of h approaching to 0 because of this h in the denominator. We can't do that because we cannot have a condition. Remember, I explained from our limits that 1 over 0 approximates to infinity. So the moment we put a 0 now on this part to say, let everywhere where there's h, let us put a 0 where there's h, we are going to remain with a 0 in the denominator like this, which makes everything infinite. So we have to get rid of this h first for us to apply the limits. So what you need is to first solve, so you can simplify the top part of your expression. Here we can see that they are like terms, 5x to the exponent of 5 and 5x to the exponent of 5, minus 2x here and plus 2x. So minus 2x plus 2x cancels. If these cancels, still you are going to see that you are remaining with the h in the denominator because this has not cancelled. But by cancelling these, we can see that this, yet we are remaining with this term, this term, this term. Remember, yet there were so many terms that we're having with h. H was to the exponent of 3, to the exponent, it was increasing. Those terms, remember, they are there here, but we are not indicating them. But if you want, you can present that one. Like I said, it's not necessary. So if you are to check here, we are going to see that these h that we are having, there is h, there is h, there is h. So we can factor out that h because it's common. So if we are to factor out that h, I want you to see what is going to happen here. Limit as h is approaching to 0 like this. If I factor out h here, I'm going to remain with 25x to the exponent of 4. If I factor out h here, there are two of them. I'm going to remain with one h. So this is going to be plus 50x to the exponent of 3h, plus and so on and so on and so on, up to this term where there is h. If I factor out this h here, I'm going to remain with -2. So this is -2, everything over h. Remember, we factored h, which was common here. We factored that h. So by factoring the h, you can see that this h and this h can cancel. That means we no longer have the h in the denominator, which was limiting us to apply the limits. Like I said, the denominator cannot be equal to 0. So now we do not have that h which was in the denominator. So it means we can now apply our limits as h is approaching to 0. So this was 25x to the exponent of 4 plus 50x to the exponent of 3h plus and so on and so on. So you're going to have and so on and so on and so on here minus 2. These terms, which are, they are in terms of h. So remember, they're in terms of h. So wherever you substitute that h, you know that there is a 0 there. So that's why we are not indicating them. So wherever there's h, we are going to substitute a 0, meaning to say here 0, 0, 0, and so on. So meaning to say we are remaining with this part. We do not have h here, so that's why we are not substituting a 0. We do not have h here, so that's why we are not substituting a 0. So therefore, our derivative, which is our first derivative of y with respect to x, is going to be given as, so therefore, the derivative of y with respect to x is going to, we are going to remain with this part of 25x to the exponent of 4. This is now a 0. There's nothing here. We are now remaining on this part with minus 2. All right, so this is how we can apply our first principles to find the derivative of the given function. So as you can see, it's a derivative, this one, which we can refer back to our general rule. Remember, from your general rule, you can differentiate this one by side by just looking at your question. You can differentiate. Remember, the derivative of y with respect to x, you multiply 5 times this, which is 25. You subtract 1. So that will be x to the exponent of 4 minus 2x. We just take our minus 2. So this will be minus 2. So as you can see, this is the same answer that you're obtaining from our general rule, which is the same answer that you're obtaining from the first principle. So take note, they are saying from the first principles. That is what you are supposed to obtain in this case. All right, so these are the typical questions, guys, that you might have. Let us check another question so that we can see the application of the first principles. How are you supposed to use your first principles to simplify these typical questions? All right, so I've got another question. Like I said, this was from the question paper of all right, so this is August 2016. August 2016, question number 4. Differentiate from first principles, 4 marks for that. Okay, I think this one is much easier. We have got y, which is equal to 5x to the exponent of 2 minus 3. So like I said, this is our f of x. It's a function that we have with respect to x, which is 5x squared minus 3. And like I said previously, that whenever you are dealing with f of x, you need, or you must determine also f of x plus h. We saw that there's a need for us to have f of x plus h, which is substituting x plus h where there is x. Here, we are going to substitute x plus h. So take note, it's 5 into x plus h squared. But there is a minus 3 that is there. So whatever that you're going to get, we must subtract 3. And remember, I talked about the expansion of a squared, this one. Yes, you can open 2 brackets. It's fine. You can expand on your own 2 brackets. Just use the identities, guys. We said this one is going to be x squared plus 2xh. So this is 2xh plus h squared. So that is h squared like this. Whatever that we get, we subtract 3. So take note, the 5 is there to expand the bracket. So it's 5 times x squared, which is 5x squared. 5 times 2, which is going to be 10xh. 5 times h squared, which is going to be 5h squared. Then we subtract 3. All right, so this is our f of x plus h in this case. All right, so now back to our formula. First principles, where we are saying the derivative of y with respect to x must be equal to the limit as h is approaching to 0 of f of x plus h. minus f of x like this, everything over h. So this is what you're going to have at the end. So now we can substitute our values or the answers that you obtained from our calculation. You can also subtract, guys. You can also find this one separate, f of x plus. You can simplify this. Then you just substitute your answer there. It's fine, you can do that. Or you can substitute as it is on your formula. Limit as h is approaching to 0 of f of x plus h. This is your f of x plus h as it is. So you're going to substitute the whole expression as it is. That is 5x to the exponent of 2 plus 10xh. So you're going to have 10xh plus 5h squared minus 3. Then take note what I was saying. It's minus f of x, meaning to say the minus here is going to affect our f of x. Everything here is going to be affected by minus. So that means here we are going to have minus times 5x squared, which is minus 5x squared, minus times minus 3, which is going to be a plus 3. Or you can simply open a bracket, minus into 5x squared minus 3. Then you expand your brackets on another stage, which is fine. But just for the sake of time and the exam, remember exam, it's also about time. All right, anyways, this is what you're going to have, f of x minus f of x plus h minus our f of x here. Then everything is over h. All right. So as we saw from the previous calculation that we made, we can simplify the numerator. Always or normally you're going to have this condition where there are terms which are like 5x squared minus 5x squared, which cancels, minus 3 plus 3, this one cancels. So you are going to remain with this part here. And if you check this part, there is h here, there is h here. So we can factor out that h which is common. So meaning to say we are going to have the limit as h is approaching to 0 of, we factor out the h here which is common. By factoring out this h, there is only one h, so it cancels this h, we remain with plus 10x. There are two h's here. We divide by 1, so we're going to remain with 1h. So that is 5h, all right? So everything is over h. Now we can get rid of the h that is in the denominator by canceling with this part, meaning we are remaining with the 10x plus 5h. So this is going to give us a limit as h is approaching to 0 of, this is going to be 10x plus 5h, where we are saying if we limit now our h to be approximating to be approaching to 0, this is at 0. So it's 5 times 0, which is 0, meaning to say we are going to remain with the 10x. There is no h here, so there's nothing that you substitute on 10x. So therefore, our derivative of y with respect to x is going to give us positive 10x in this case. All right, so that is it, guys. That's how you play around your derivatives, the first principles, together with the expansion of brackets. The more you understand your expansion of brackets, it makes this first principles easier, because much of this, you see, it's just expansion of brackets, collecting of like terms. So make sure that you also use your calculator properly in the simplification wherever you're adding or subtracting. All right, that's it. Let's check another part of our question, which is here from August 2019, question number 1. We are given to differentiate on 1.1 from first principles if f of x is equal to 2x to the exponent of 4. All right, so this is like this. F of x is equal to 2 over. So this is 2 over here. All right, so this is our f of x, guys, the one that you are given. So already here we are given our f of x. Our f of x it's 2 over x to the exponent of 4, which is something else, guys. A fraction is something else, this one. So what can we do? If we are to consider this, it means the same thing. Remember, from our laws of exponents, you can write this on top as to the exponent of -1, so that we properly understand what you're given there. So meaning to say this can be given as f of x is equal to 2x to the exponent of -4. That is, in this case, we have written in a basic way that we understand our derivatives in this case. That is the normal format that we have. This one, it's a normal format that we have. But from the normal format that we have, how can now we express it in a format of first principles? Remember, we need f of x plus h. So that is the stages that you're going to take. So here we can work with f of x plus h, where we are saying f of x plus h simply means in place of x here, we are going to substitute x plus h. So this is 2 into x plus h like this to the exponent of -4. This f of x, for us, it is no problem because there's nothing that you do there. You just leave it like that. But on this part here, the f of x plus h, what you are given there now is our worry to say, how can we expand this? Because it's a bracket being raised to the exponent of -4. So it means we are supposed to think of the binomial expansion now. There's a negative exponent here. So meaning to say, for us to expand this, there is no way. Let us think of the binomial expansion, whereby we are going to have f of x plus h being equal to 2 is just there to multiply whatever that you're going to have at the end. So remember what I said, x is going to be raised first to the exponent of the one that you're given, x to the exponent of -4. H at that moment is being raised to the exponent of 0, plus whatever that you do on x, you drop the exponent. -4 multiplies x. So it's going to be -4 x to the exponent, you subtract 1, just like derivative, you subtract 1. So -4 minus 1 gives us -5 in this case. So this is going to be -5, while h is increasing. So this is h. All right, let's just wait. H to the exponent of 1 over 1 factorial. Okay, plus we do the same thing. This one, you drop the exponent, -5 times -4. That is going to be +20. X to the exponent, we subtract 1. So that will be a -6. H is increasing to the exponent of 2 over 2 factorial. So guys, this is not going to change. This is not going to end. This part that we see, it is not going to end. We are going to have this and have this and have this and have this until I do not know. So what is important is for you to indicate maybe 4 terms, 3 terms, depending on what you have. So as for me, I'm just going to end here, but I think you see what I'm trying to say. So this was going to be up to infinity. It was not going to end. We're going to expand and expand and expand and expand up to but if it was a positive like that one that was to the exponent of 5, that one it was going to end. But just because I said these h's, that as you can see, the h here is to the exponent of 2. This next one, it was going to carry to the exponent of 3. The next one to the exponent of 5, but it's not ending. So why wasting our time? Because we are going to subtract that h at the end. So instead of wasting that, let us leave it like that. There's nothing that you're going to do. So that is it. All right. So let's move on now to the expansion of the bracket. Or before that, let us just simplify inside the bracket so that we can expand later on. H to the exponent of 0, that's 1. So this one remains as x to the exponent of -4. Then here we've got -4 divided by 1 factorial, which is -4 x to the exponent of -5h. All right, here we simplify 20 divided by 2 factorial. This is going to be 10. So it's going to be plus 10x to the exponent of -6h squared, plus and so on and so on. All right, so we can multiply by 2. 2 times x here, that's 2x to the exponent of -4. 2 times -4, which is -8, x to the exponent of -5h, 2 times 10, which is +20, x to the exponent of -6h squared, and so on and so on and so on. All right, so instead of writing these and so on, guys, we can just leave it like that, or you can just indicate that there's the other terms that we have there. So this is your f of x plus h in the expanded manner, depending with the number of terms that you're going to use or that you're going to expand with. All right, but at least you have 3 terms. At least 3 terms. All right, so meaning to say 3 or more. All right, so you can at least have 3 terms in this part. All right, so taking this, I want you to take this f of x plus h. Now we bring it to our formula. Remember, here we are going to have our formula for our derivative, which states that the derivative, or okay, this one is already given as f of x, so we are going to have it as f prime x. In this case, the first derivative with respect to x is equal to the limit as h is approaching to 0 of f of x plus h minus f of x, everything over h in this case. All right, so that means we can substitute our values in this case. So this is going to give us the limit as h is approaching to 0 of f of x plus h. I want you to take this value as it is, substitute this value as it is, this one as it is. All right, so this is going to give us, all right, so this is going to give us as it is. So that was 2x to the exponent of minus 4 minus 8x to the exponent of minus 5h plus 20x to the exponent of negative 6h squared plus and so on and so on. Remember, then after substituting our f of x plus h, we are going to subtract f of x. So f of x this time, it's a single term. It's not a bracket. It's not an expression where you need to open a bracket or you need negative must multiply each and every term. This one is a single term. So it's direct minus 2x to the exponent of minus 4. And everything here is over h. So if we take note of what we have, everything is over h. And here we can now simplify. We've got like terms, 2x to the exponent of minus 4 minus 2x to the exponent of minus 4. These two we will cancel. So that means we are remaining with this part inside. So we're just going to remain with the limit as h is approaching to 0 of, we can factor out our h since we are just remaining with these terms. So these terms, they are containing h and so on and so on. They are going to contain h. So we can factor out h from the first one. That will be minus 8x to the exponent of minus 5. H and h here cancels. Then we factor out h here. There are two of them. So we remain with 1. So it's going to be plus 20x to the exponent of minus 6h plus and so on and so on and so on. These terms that we are saying and so on and so on, they're in terms of h. So they have got no issue. They just represent a 0 later on. All right, so that's it. We can cancel the h and the h here. Then we are going to obtain our expression as the limit of h is approaching to 0 of, so this is going to remain as minus 8x to the exponent of minus 5 plus 20x to the exponent of minus 6h plus and so on. So these terms, they are containing h. So the moment we limit h to 0, this one will be a 0, this one will be a 0. All these terms, there will be 0, 0, 0, 0, 0 up to the last, in fact, up to infinity. So meaning to say, we are going to remain with this term at the end, the part that do not have x. So therefore, we can conclude that the first derivative with respect to x here is going to give us negative 8 to the exponent of negative 5. All right, so that's it. Or you can write it as a fraction, that is negative 8. So this one is going to remain as negative 8 over, we get rid of the negative. So it is going to be x to the exponent of 5, like that. Okay, so like I said, yeah, it's just another simplification that you can do, or you can simply leave your answer like that. It's one and the same thing that you can have. Or the first derivative with respect to x is equal to negative 8 over x to the exponent of 5. That is writing as a positive exponent the same way that it was before. So you can even do as much question that is good fractions, as long as a fraction like this with a certain exponent. There's another one when it is 2 over x or any number over x, not x squared or x to the exponent of 3. When it is just x, that one you do it with another way, not this way of expanding. Let's just hope with time I'm going to have such type of a question. All right, so just hope with time. But for this one, I think we are together. So the major part here is for you to revise again and again your binomial expansion so that you understand what exactly is taking place that can help. All right. Anyways, let us check the other part of our question. This was from August 2021, question number 5. 5.1, we are given to differentiate with respect to x from first principles. Y is equal to ax squared plus bx plus c. That was 5 marks in this case. So as you can see, it's the same thing, same approach, same way like the previous way. This is our f of x. Our f of x is equal to ax squared plus bx plus c. So all we need is to find f of x plus h, because we are going to need it on our formula. So we are going to have f of x plus h, meaning to say in place of x here, we are going to substitute x plus h. So this is a into x plus h squared plus b into x plus h plus c. So this is x plus h like this plus c. So the first part we talked about this type of expansion. Remember, we got something like x squared plus 2xh. So this is 2xh plus h squared like this. All right. Then we multiply. The second bracket is being affected by b. So it's b times x. So it's going to be bx, b times h, which is going to be bh plus c. All right. So that is it, guys. We can expand the first bracket because you have got a affecting everything. So it's a times x squared, which is ax squared, a times 2xh. So this is going to be plus 2axh. All right, a times h squared. This is going to be plus ah squared. The rest, these terms, you write them as they are because they are not part of our bracket. They're outside of the bracket. So it's bx plus bh plus c. So this is our f of x plus h in this case, the one that we are going to substitute into our formula. So like I said, you can even find f of x plus h, f of x plus h minus f of x here if you want, or you can just go back to your formula, which states that the derivative now of y, okay, so this was given as the derivative of y, let me write it aside here, of y with respect to x is equal to, or let me write it on top, then I'll write it down here. So it was dy dx, all right, sorry, dy dx here is equivalent to the limit as h is approaching to 0 of f of x plus h minus f of x, everything over h. All right, so I just want to substitute everything here now on this one. So we are going to have the limit as h is approaching to 0 here of, then let us substitute f of x plus h. This is our f of x plus h as it is, you write as it is. That is ax squared plus 2axh plus ah squared bx, everything as it is. So this is going to be plus bx plus bh plus c. All right, now we are going to subtract f of x, and our f of x here, it's an expression. And I told you that for an expression, you multiply everything by the negative. So that means it's negative times ax squared, which is negative ax squared. Negative times a plus bx, so that will be a negative bx. Negative times the minus b, the minus c, the plus, so that will be a minus c in this case. All right, so that is how you affect every term with a negative, but this whole part is over h. All right, like this over h. Let us see what you're going to have. Let us see. We've got like terms. If we consider this part and this part, so these two can cancel. All right, bx and minus bx, these two can cancel. Plus c and minus c, so these can cancel also. So meaning to say we are remaining on top with the limit as h is approaching to 0 of, this one is going to be 2axh plus ah squared plus bh. All right, so that is the only part that we are remaining, but everything is over h. So meaning to say we can now factor out the h so that we can apply the limits. We are limited here because of what? The h in the denominator. So factor out h in each and every part. So if factor out h here, we are going to remain with 2ax plus ah, because there are two, so you're going to remain with 1h. Here there is 1h, so you're going to remain with plus b in this case. All right, so that's plus b, everything over h. All right, now the h and the h can cancel, so that means we are saying we are just remaining in this case with our limit. H is approaching to 0 of 2ax, so this is 2ax plus 2ah plus ah plus b, like this, where we are saying h is approaching to 0. it's actually a 0 that we are having there. But where there is h, where there is this h here. So that means from our h that we have presented with a 0, this part is going to remain as it is. This part is going to remain as it is. So therefore, our dy dx, which is the derivative of y with respect to x, is going to give us 2ax plus b in this case. All right. So that's it. You can even prove from your normal derivatives that you are used to. Remember how to differentiate from our basic derivatives. You can even prove to see if it is exactly what we are supposed to obtain. That is the advantage part of our derivatives. You can go back to a general rule and prove back and see if it is exactly what you're supposed to have. And this is what exactly you're supposed to have. So let us have another question. We've got another question, which was August 2018. Differentiate y is equal to negative x cubed by using first principles, and that was 4 marks. All right. So let us see this one. What are we going to have here? So we're given that y is equivalent to negative x cubed, which is our f of x. So our f of x is equal to negative x cubed. That means here we can work on finding our f of x plus h. Where there is x, substitute x plus h. So it is going to be minus into x plus h cubed like this. For you to expand x plus h cubed, you can do the you can break this into 2 brackets. Remember, from our exponents, a times a is a squared. What we are simply doing, we are adding the exponents. So if this is a times a squared, we obtain a to the exponent of 3. We are adding the exponents. So in order for us to obtain these 3, it means we can use one linear and one quadratic. So this can be given as minus a linear expression of x plus h into the quadratic, but it will be of x plus h. So that's x plus h squared. Just like a times a squared is a cubed. So you haven't changed anything. Why writing in this way? That is the question. Why dealing with x squared? Because there we talked about the identity. Remember that I talked about to say this can be taken from minus x into h into this one taken from our identity. We got x squared plus 2xh plus h squared. So meaning to say, instead of you wasting your time, that is the advantage of having this way. So the last thing that we need is to expand now with this bracket. So you can even ignore the negative if you want. Just ignore this negative, just as if it's not there. Expand everything by x. So it's x times x squared. That is the first part, which is going to be x to the exponent of 3. X and this 2xh. So it's going to be 2x squared h, x and h squared. So this will be x h squared. We are done with x, but there is h here. So it's h and x squared. So it's going to be x squared h. We just take the same format like this one. We are starting with x followed by h. So let us do the same way to maintain the order that we are having. All right, so that was h here and x squared. Then we have got h versus this part of 2xh. So h and h gives us a squared. So that's 2xh squared. Then we've got h versus h squared, So h and h squared is going to be h to the exponent of 3. Now we can expand by our negative, or we can collect our like terms before. Yeah, let us just collect our like terms because we've got like terms here. So that will be negative x cubed. Here we've got like terms, x squared h. This is x squared h. So we can add, this is same as 1. So it's 2 plus 1, which is 3. So this is going to be 3x squared h. Also, we've got like terms here, xh squared, xh squared. So this is same as 1 here. So it's 1 plus 2, which is 3 also. So this is going to be 3xh squared. Then the last term is h cubed. We do not have any like term here. So that is our f of x plus h, but there's a negative outside of the bracket, which waits for us to expand. Negative and this, that will be negative x cubed, negative 3x squared h, negative 3xh squared, negative h cubed. Everything is being affected by the negative outside of the bracket. So this being our f of x plus h, what can we do now? We need to bring this to our formula. But like I said, you can even also determine your f of x plus h minus f of x if you want, or you can just take this back to our formula. So our formula was stating that the derivative of y with respect to x is going to give us the limit. So let me just have so that we can substitute. I'm just rewriting so that we can properly see our formula. So this is the limit as h is approaching to 0 into f of x plus h minus f of x like this over h. So if we are to consider this, this is going to be equal to the limit as h is approaching to 0 of now f of x plus, which is this part as it is. This is our f of x plus h, which is minus x cubed minus 3x squared h minus 3xh squared minus h cubed minus f of x. We are subtracting. This is our f of x, the one that we are subtracting. So if we say minus, it gives us a positive. So this will be plus x cubed. All right. So this is what you're going to have, but everything here is over h. So from this part, we are going to have this whole part over h like this. So this is you and your simplification later on. So the derivative of y with respect to x is going to be limit as h is approaching to 0. So let us see what is happening here. These are like terms, x cubed and x cubed. So you take the part of x cubed and x cubed. So this one minus x cubed and plus x cubed. So this one cancels. But if we check the remaining terms, they've got h, we've got h, we've got h. So we can factor out that h that we are given. So by factoring out h here, we remain with minus 3x squared. If we factor out h here, we are going to remain with minus 3xh. There are two of them. If we factor out h here, there are three of them. So if we factor out h, we are going to remain with the two of them. Everything in this case, all right? So take note, we've got our h here, the one that we factored out here. Everything is over this h. All right. So that is what you're going to have. So the h and the h here will cancel. So this one and this one outside of the bracket cancels. We are remaining with our limit as h is approaching to 0 of this expression now of minus 3x squared minus 3xh minus h squared, where we are saying we can apply our limits now as h is approximating to 0. There is a 0 here, there is a 0 here. So therefore, our derivative of y with respect to x is going to give us this term of negative 3x squared. All right, so that is what you're going to have at the end, which we can also prove from your general rule if exactly you're obtaining minus 3x squared. All right, guys, that's what I had for you guys for your preparation of exams. Understanding that exams are actually ahead of time. We do not have time, much remaining time. We do not have that. So let us try to work as much questions add with your question papers so that you can properly understand how to evaluate these, how to find the derivative from the first principles. This is where our derivatives were taken from the gradient concept. We generated this formula, but in our syllabus, we are not formulating these formulas. You need to know the formula, this formula, and to apply the formula. That is what you are required to do in your syllabus, not to get to say, where was this formula taken from? How? Okay, that one is not part of our syllabus. All right, guys, that's what we had from Meson African Motives, working on mathematics info. Till we meet again.